Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, in this video we'll discuss about question number 14 NEET Physics paper 2016. Students, in this question number 14, it is about diffraction. In a diffraction pattern due to a single slit of width A, this is a single slit of width A, so this distance is A, the gap is A. The first minimum is observed at an angle of 30 degree. Suppose that the first minima is observed at 30 degree. So this is the first minimum. This is observed at 30 degree. When light of wavelength, the light that is used is having wavelength equals to 5000 Armstrong, is incident on the slit. Here the question is where the first secondary maxima is observed here. I write here is observed at an angle of. So this is so this part you have to write here is incident on the slit. The first secondary maxima is observed at an angle of. That means he's talking of the first secondary maximum. This is the primary, the central maximum, and this is the first secondary maximum. So this first secondary maximum is found here. So the question is to find this angle. Okay, I'll call this as a theta 1, suppose. Okay, so where this theta 1 is found, or theta 1 prime, say, I will use this as a theta 1 for minimum. So for minimum we are using 30 degree theta 1, and for maximum prime we are using notation prime. So we are actually going to find theta 1 prime. This is the diffraction pattern. Now we know that for minima, general expression for the condition is that A sine theta n equals to n lambda. This is the condition for minimum. For first minimum, here you can see that is the first minimum. So for first minimum, this n should be 1. In this expression, if I put n is 1, this is A sine theta 1 is 1 into lambda. So that is A sine theta 1 is lambda. A sine theta 1 is lambda. So from here I'll write theta 1 is given as 30 degree for first minimum. So A sine of 30 degree equals to lambda. So that means A sine 30 is half, A by 2 is lambda. So, or A is 2 lambda. This is one expression I am getting. Okay, we'll use for secondary maxima. So now we'll switch to the second case of secondary maxima here. This angle I have to find. The general expression for secondary maxima is given by a sine of theta n dash equals to 2n minus 1, okay, 12 plus 1 lambda by 2, 2n plus 1 lambda by 2. So in this expression, if I put n is 1, then I'll get this n is 1 implies first secondary maxima. First secondary maxima I'm getting. So a sine theta 1 dash equals to 2n, n is 1 plus 1 lambda by 2. So from here a sine theta 1 prime equals to 3 lambda by 2. So we must remember this, that the part difference is 3 lambda by 2. Okay, so the part difference, it becomes 3 lambda by 2, where you get the first maximum after central. So sine of theta 1 prime equals to 3 lambda upon 2a. Now we have to substitute this value, that a equals to 2 lambda. So if I put a equals to 2 lambda here, then this becomes 2 into 2 lambda, which is equal to 3 lambda by 4 lambda. Lambda will cancel. So I'm getting sine of theta 1 prime equals to 3 by 4, or theta 1 prime is sine inverse 3 over 4. So this is the angle where the first secondary maxima is formed. So if I see the options, where the first secondary maxima is formed, you have to find the angle, that is theta 1 prime, and I'm getting it sine inverse 3 by 4, which is the first option. So therefore the option number 1 is the correct answer to this question. Okay, thank you.